Welcome to Unlock Layouts. In this video session, we are going to discuss how the deep and well diode extractions are happening in the LVS window. Based on the cross-sectional view, we are trying to understand the parasitic extractions of the diode. Let's start the video. I have given my personal LinkedIn account here. If you want to connect and follow me, kindly do that. So this concept we can easily understand by using the cross-sectional view of the CMOS with deep and well and without deep and well. See here we have a figure B. So with this, the condition is here we don't have any deep and well layer. This is the normal N well and the P substrate layer. If you disabled diode extractions option in the LVS results, okay, there is a LVS rule script. So in that LVS rule script, either we need to enable or disable of the parasitic extractions of diode. So if you disable that, the tool will never identify that what kind of parasitic diode formation is here and whether there is a diode formation is present or not, it never consider. But even though we have a parasitic diode here, so we have a N type of material here, we have a P type material here. So this both can acting as a diode right here. But this is the parasitic diode, but this is not actual diode. Now, if you enable that LVS parasitic extraction options of the diode in the LVS report, so the figure A, we need to add the deep and well layer. So we know deep and well layer is the type of N type material. Okay. So then we have a P substrate layer. So this P substrate layer by default we know by the name we can easily identify it's a P type material. Then inside we have another P well. So this P well is the another P type material. So we have a P and junction diode across these two, and we have a N and P junction across these two. So totally we have a two diodes. One N terminal is common for each diode, whereas we have a top side another P type material, bottom side we have another P type material. So totally we have a PN junction and NP junction diodes formation here. So in the layout also, we are trying to implement the same structure of the diagram A. So there is a device, the device is under the deep and well. The deep and well guard ring is also consists of N well. Okay. So what is the need for this N well here, first of all? Okay. See, deep and well layer cannot directly connect to any type of potential. See, we need to connect this deep and well potential to VDD terminal, right? So how do I connect my power signal to this deep and well layer? So I don't have any additional masking layer in the foundry to directly inject my VDD signal to the deep and well. So then how can I inject my supply here? So how can I connect my supply here? So that's the reason, even though if you have a deep and well layer, through N well, this deep and well layer will get energized. So because there is, as we already discussed, that there is no difference between N well formation and deep and well formation. I'm talking about the only the material wise, not in the fabrication wise. Deep and well and N well is the same material. It's a N type. It's a N type material. Okay, but deep and well will be fabricated underneath of the device. Like it will be even more deeper than the normal N well. Okay, so how this deep N well will take power? This deep N well will take power through N well. This N well will be connected to the tap connection N tap. This N tap we are connecting to the VDD signal, right? So that's the reason we need to keep the N well layer and as well as the deep N well layer in the layout window. So the diagram what I'm showing here, this is exactly overlapped in the N well and deep N well. See here, this is exactly overlapped. In this diagram A, the N well layer and deep N well layer is exactly overlapped in the left hand side, in the right hand side also, and then see here as well, this is exactly overlapped. So the N well layer is not away from our deep N well. Our N well layer is, our deep N well layer is also exactly overlapped with this structure. So here the tool will identify that there is a N well layer, there is a P substrate layer, and there is another P substrate layer. So it can easily identify that. So it can easily start making the diode formation here. This is one diode, this is another diode. Okay, so this will be connected to D pen well, this will be connected to our P substrate potential, and this potential of P substrate will be connected to the common ground. Whereas, okay, now here in this diagram, what we have to see our N well layer is slightly inside our device. So what we discussed in the layout, our N well layer is outside of the D pen well, first case, and another case is our D pen well is inside the layout. So this is our case number 2. Okay, so this is our case number 2. So deep N well is inside the N well, whereas you have some extra extension of N well in this portion. Okay, so how the tool will identify now, since it is a parasitic extraction is enabled, now there is a N well potential. Okay, this N well potential and this is the deep N well potential, both are considered as the same diode. Then we have a common substrate in the bottom P. So this is a one parasitic diode. Then where you don't have any deep N well in this particular area, so this area where we don't have any deep N well area, so this is also N type material, and we have another P type material. So this also considerably another parasitic diode. So this net, what is the net name here? So this name is connected to VDD in our case, but here P substrate, still we have not assigned any P substrate here because it's a global substrate. We have not assigned any power to the P substrate. So this can be identified either the random name, maybe in our case this is net number 8. Okay, so another case here as well. For example, I am just extending my deep N well outside of the N well. Okay, so literally I have extended small amount of extension. I have done it in my deep N well layer. So now in this case, how my tool will identify that? See, this area, whatever extension is there, exactly here, there is a small extension of deep N well. So this deep N well extension now can be considered as another diode. So that is how our tool will act. So this is one N type material, and bottom of that we have a P type material here. So this is the P type material. So this N and P, again it will create as another parasitic diode, whereas by default here we have a deep N well parasitic diode. Okay, in this deep N well parasitic diode, this deep N well is already connected to VDD potential. Okay, P substrate is already connected to some ground. But whereas here we have some empty spacing between this area. Okay, because of uneven enclosures, because we have not done the layout properly. So because of that, the tool will identify that even there is a small area of extension in this case, in this area. Okay, hope you are following my mouse cursor point. So in this area, so this small portion of N well also considered as a one type of N type material, and bottom of this we have another P type material. So this is also considerably called as another parasitic diode formation. So now in this case, our layout end terminal is connected to, already it is connected to VDD. But where my P terminal is connected, my P terminal is not connected anywhere. So this can be identified by the LBS tool, either net number 9 or net number 8. Okay, so that's what we saw in our LBS extraction report. Maybe there is a high amount of chances, maybe those who are not able to understand with respect to the layout, they can easily able to understand with respect to the cross-sectional diagram window. Okay.
I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel and don't forget to click the bell button.